thank you all for being here, attending to this presentation. It's a nice opportunity for us to be here, showing our work. And, well, I will try to follow this very simple agenda. And first I will talk about how HPC evolved at Petrobras for you to know a little better about us. Then I will talk about how we are now. And then talk a little bit about cloud and conclude this presentation. So let's start from the beginning. This is a nice picture of our first seismic processing machine. And at the time, we used it for running Western geophysical software, seismic software. And as many other companies, we used IBM mainframes for decades up to the mid-90s, when we started with risk machines, basically IBM SP2 and SGIs. We did have other machines like Sun Microsystems and HPC for other. Oh yeah. Sorry. Well, are you hearing now? No?
If not, we can try this.
Well, much better. Okay, sorry about that. And, well, basically, as many other companies, we used the IBM mainframes up the mid-90s, and I worked with the IBM mainframes because I started in Petrobras in 1987, although I didn't work with this machine. Well, yeah, no, that's bad. Okay. And in the mid-90s, as many other companies, we started with IBM SP2s and SGIs for HPC, and for other workloads, we had Sun Microsystems and HP. And basically, the SP2s we used for Western Geco Omega, seismic software, and the SGIs we used for Landmark Promax and also for our own applications. And we built our first x86 cluster in 1997, and I don't have a picture of this first x86 cluster, but I have a picture of our second one that we built in 1999. We didn't have much money at that time, and so it was a quite cheap machine, but in fact, it was able to run a good deal of seismic at the time, and in a way that we basically stopped to buy risk machines. And even though we had the x86 just for our own applications, okay? In fact, the power challenges, we use it to run our own applications, seismic imaging and so on in the power challenge. And so we have to recode the applications from a RISC shared memory Unix machine to a distributed Linux x86 machine. And then we almost didn't buy any more RISC machines, and we built a number of x86 machines, including this one. This was the first machine that we have in the top 500. Well, please note that our target is not to be in the top 500. The goal of this machine was to run seismic, but we do believe that being the top 500 is nice, okay? But it's not our target. It was our first machine in the top 500 and the only one that we had in the top 500 without GPUs. Because in 2007, we started a project that we studied a few different architectures, including FPGA and so on. But the main options were the cell processors that we could find in the PlayStation 3 consoles and the GPUs. We ported a seismic imaging code to this cluster. We built this small PS3 cluster that you see in the picture in the beginning of 2007, and we ported a Kirchhoff time migration to to this cluster. And later on, we ported the same seismic code to a GeForce. And then we were able to compare both architectures with the same seismic code. And you should know that the best option was the GeForce GPU, the GPUs. And so, as a result, in fact, we have a number of published results. The first one in 2007. And as a result, we built our first GPU cluster in 2008. We built it with just one rack and to port the code and test and so on. And in 2009, we expanded it to 3 racks. And with 3 racks, it was equivalent to a 4,000 node CPU cluster to run our application. So it was very good for seismic. And with this cluster, we were able to get 1,000% gains in terms of costs and power consumption, and also data center space. So we moved to the GPU, started to move at that time in 2008, but it was not to get a 10% or 20% improvement, okay? It was to get a 1,000% improvement. And another point that this machine was very good for seismic because it had a very good single precision performance, but it didn't have good double precision performance, so it was very good for seismic, which was our target, but it was not good for the Limpec or the top 500, but we didn't care because our target is seismic with that machine, and as I said, being in the top 500 is nice, but it's not our goal. And then we built a number of other machines, basically the Griffo 2 and Griffo 3, which were also good for seismic, but they were not good for Limpec. But when Nvidia launched the Maxwell GPUs, we were able to build the Griffo 4 that was very good for seismic and also good for the Limpec, so it was ranked in the top 500 as the biggest supercomputer in the industry at that time, oil and gas industry. Well, we know that not all companies list their computers in the top 500, and so maybe at that time we could have other bigger oil and gas computers. But anyway, for us it was quite an achievement. Okay, it was a landmark for us to be in that position. We were not so prominent any other time. Okay, but at that time we were with a very good infrastructure for HPC, for seismic and reservoir and so on. But then we had a big crisis, and the price of the oil dropped a lot. But for sure, it was not the only problem that Petrobras had at that time. We had lots of problems, in a way that we basically stopped to invest in HPC for a number of years. And because of that, after having the biggest top 500 energy supercomputer in 2012, a few years later, our infrastructure was basically obsolete, okay? And so in 2008, we built a plan to revamp our infrastructure, but we didn't have the money, the resources, the data center, and the budget and so on to do it at once, and so we had to do it in waves, which led to some fragmentation, and which means that nowadays we have more clusters than we would like to have, okay? We have more than 10 clusters, and we could have about 8 maybe, something like that. And also the plans have to be modified to the number of issues, especially the COVID-19. And so nowadays we have a very nice infrastructure for our business. It's running quite well, but it's more complex than we would like to have, okay? And one reason for that is that we have different workloads. I won't talk too much about that because it should be very similar to everybody else here. We basically run more seismic and reservoir simulation, but we have a number of other workloads like geomechanics and petrophysics and so on. But I would like to point out that while our reservoir workload is quite simple, because most of our jobs run CMG applications, and our seismic environment much more complex. We have software from Shearwater, CGG, Paradigm, Landmark, and we have about more than 5,000 GPUs, and 90% of them is to run our own software, so it's a much more complex environment. And so we can't simply have the same cluster for reservoir simulation and seismic, and even inside seismic we need different cluster for geovation and our applications and so on, and geodepth and so on. And we also have two different data centers. One rented data center where we have most of our seismic, and one proprietary data center where we have a mix of workloads. We managed to have all our reservoir simulation and research center clusters in the proprietary data center, but the seismic is divided in between two data centers. Both data centers are in Rio, but they are not very close one to the other. Sorry here, well, let's see if I can show you. Well, one data center is in one side of the town. Sorry, I believe that. Well, one data center is here in an island in the Guanabara Bay, okay? And the other close to the sea, and the other data center here close to the mountain. So they are about 20 miles away, one from the other. And, well, this is a picture of our proprietary data center. It's located in an island. In this island, we have research centers from a number of companies and also a big university. And in fact, most of you can see in this picture is not the data center, but our research center. In fact, the data center is this white box here. In fact, it's the less interesting thing in the picture, for sure. But if you want to visit it, it will be really nice. David was there a few months ago, and Rich also, and it will be a pleasure. And I won't say that it is less interesting thing in the picture because my office is here, okay, near this window. So if you want to visit, you are welcome. And well, let's first talk about the machines we have in this data center. As I said, we have a number of machines for reservoir simulation. Today we have Guaricema, Libra, and Búzios. And so you could have maybe one or two machines clustered for reservoir simulation, but we have 3. But the node configuration is quite similar, so we basically manage them as a single cluster. Okay, and we are building a new cluster with 400 nodes, so we should have about 1,600 CPU nodes for reservoir simulation. And we don't use GPUs for reservoir simulation. Basically, we don't have GPUs for reservoir simulation. And we have 2, in fact, we have now one machine for the research center, Athena. And in fact, Athena is 2 clusters because we have a GPU cluster with almost 200 V100s, and we have another partition with 256 CPU nodes, and we are building a quite bigger machine for the research center with 700, 800 GPUs, okay, Gaia, but I don't have a picture of it. It's not installed yet. And these are the machines for size that we do have today in our proprietary data center. Both are for geovation, Aquila and Leão. Aquila we built in 2009 for geovation, and then in 2021 we decided to expand our geovation environment, so we built Leão. Leão has GPUs and Aquila doesn't have GPUs, okay? And for seismic, we have a number of machines, and as I said, we had to build our infrastructure in waves, and so I will talk just about the bigger ones. And we have Phoenix, Atlas, Dragão, and Pegasus. They have altogether almost 5,000 GPUs. And as we had to build our environment in waves, we have 4 machines. We could have maybe 2 to run our applications. And as a result, we had the Latin America top 1 supercomputer in the last 4 years, okay, in a row. But it was really not a choice, okay? It was a consequence. And the bigger one is Pegasus. Let's talk a little more about it. Well, it's number 33 in the top 500. And again, we know that there are several companies that simply don't list their machines in the top 500. So for sure, there are other bigger machines out there. And it has 2,000 GPUs and 20 petabytes in 3 different Lustre file systems. Okay, and I have a picture, a movie, a small movie about Pegasus, and let's see it. Sorry if the subtitles are in Portuguese. I don't have an English version of it. Okay, but it's a nice machine. It's divided in 5 rows. Okay, the bigger rows have, I believe, 14 racks, including the Lustre file systems, and also have some racks of CPU nodes in this environment. Well, it's a nice machine. It's located in the rented data center, the one that's close to the mountains. Thank you. Well, and as I said, in 2018, we had infrastructure that was not good for our business. We had about 3 petaflops, and please note that in these numbers here, I plot all our capacity, including GPUs, CPUs, all our clusters, including those ones that are not in the top 500. And these numbers are in petaflops FP64, which you use it to be the same as the petaflops R peak of the top 500, but since the A100 GPU, they are not the same, the FP64 and the R peak. And we had about 3 petaflops in 2018, and in 2019 we were 3 times bigger, and about 5 or 7 times bigger in 2020. And last year we installed a number of clusters, especially Pegasus, that expanded a lot our capacity. And now we have about 80 petaflops of capacity, okay? And well, let's talk a little bit about cloud. Well, I don't know if I have anything new to say here. Everybody knows that cloud is interesting, but it's somewhat complex to go there, especially for seismic, and it may be also quite expensive if used without care. So we are trying to use it with care. And in fact, for us, as I said before, our reservoir simulation environment is, let's say, much simple than we have for seismic. And also for machine learning, it would be much easier and cheaper to move it to the cloud. So what we are trying to do, and this plan is being reviewed revised all the time, and so we may change the plan. So, but we plan to have a part of our production workload of seismic, reservoir simulation and machine learning run in the cloud in maybe this year, next year. And for seismic, it will be much more difficult, but we plan to start with development code, seismic development code in the cloud and so on, okay? So we believe that the cloud will be an important part of our ecosystem, even though it won't be so relevant as our on-prem resource, at least for the next few years, okay? And so, let's conclude the presentation. As you should know, HPC is very important for our business. Everybody there knows that. And we started with 1969 with an IBM mainframe for seismic. We had our first Linux cluster in 1997. We started using GPUs in 2008, and we should reach about 6,000 GPUs in 2023. And again, please note that we moved to GPUs not to get a 10% improvement or 20% improvements. So we moved to GPUs because it was 1,000% improvement. And since 2018, we expanded our capacity by more than 20 times, but we now have a somewhat complex environment. Everybody knows that building a big machine like Pegasus 33 in the world is not easy, and to build a number of them, it's not easy at all. But it's running quite well, and we are quite satisfied with it, and the cloud should be important for us. And that's it. I would be glad to take any questions if you have.
Hi, hello. You have more than 10 cluster, correct? So are they all commodity cluster or it's a proprietary cluster?
No, all of them are commodity. Since 1997, we are quite commodity. We only buy something that's not commodity if it's really necessary. Even it's also because as a government company, we have some rules to follow. It's hard to justify to, for example, choosing one technology over the other. For example, I would prefer to choose the file systems that we use, but we don't really have this option. But anyway, we do prefer being commodity. And for example, we would prefer not using Red Hat. We would prefer using CentOS, as we've been using for a long time. But I'm not sure if you are going to have this option. We have the security guys also, and security is very important. Information security is very important, so we should take care of it. And we are quite commodity. We only buy anything that's not commodity if it's really important to do so.
Thank you.
Thank you.